Okay, this is a quick video to show my demo for the packet filter. This video is basically just in case everything stops working. I VNC'd into my work computer, so let's start by looking at my Git repo. This is the code that I put together, which implements my packet filter IP. The IP itself is inside this folder, but all the sources and other supporting files are in the rest of it. I'll talk about them as they come up. What I have going on right now is an FPGA connected to my computer through two cables. The first cable is this black one here, that's the USB cable. The JTAG and the UART interface to the FPGA go through the USB cable. We're going to be using the JTAG to interact with the ILA. There's an ILA in the design. I'll show you that in a second. And also, the design does send back some, debug data over UART, and we'll see that as well. The other cable is an Ethernet cable, and what's going on in this demo is we're going to be sending commands to our design over Ethernet, and that's going to change what the packet filter does. Okay, so what exactly is the packet filter? Basically, it's an IP core that has three inputs. One of the inputs is for putting in new instructions. Another input is for copying packets into some local memory. And the last input is for forwarding out packets that are accepted by your code. To put it differently, the whole point of this core is to essentially act as Wireshark in the FPGA. We look at a bus going between two IP cores somewhere else in your design, and we copy everything into this local memory. And then given a filter specification in the instruction memory, we have this little CPU that's going to decide whether or not to forward that packet out. And of course, it gets forwarded out in the external read interface. So what I have on the FPGA is this design. We can see the packet filter here. This AXI light bus is where we send in the commands to upload new filters. And the rest of this block diagram is basically just to hook up a microblaze and the Ethernet, which is around here somewhere, I think that's it, and hook up the Ethernet to this interface. The only other important parts of it is this fake data. This generates some test data, and it's supposed to represent something that might be moving between two IP cores in your design. And we have an ILA to show the packets that are accepted by the filter and forwarded out. This particular version of the IP has AXI light for control. It has AXI stream for snooping. That's what I call looking at a wire. And it has AXI stream for forwarding. That's what I call sending out accepted packets. Okay, so now I'm going to open the hardware manager here. Ignore these signals here. They're just left over from the last time I ran this. These are the lines that are put into the ILA, the forwarding lines from the packet filter. Okay, but as you can see, I've triggered the ILA on any change in tvalid from the forwarder, and right now it's just waiting for trigger. So let's talk about what the fake data sends out. It sends out 3 packets in quick succession over and over and over again. The first packet is this one that I just sort of made up. It has a bunch of random stuff in it. The second packet, by the way, what do I mean by packet? It's an AXI stream interface, so basically a bunch of data before sending TLAST, right? And it's the natural meaning of packet when it comes to AXI stream. This second packet is something that I copied from my computer. I just asked it to ping another computer on the network, and I copied this packet out, so it uses TCP. And then this third packet is the same as the first one. And what will happen is the fake data that you saw, it will push out all these 3 packets over AXI stream, one right after the other, and then it'll wait something like 200 clock cycles, and then it'll send them all back out again. So it just keeps doing that over and over and over. Okay, the last thing that you want to see is in my repository, I have included this sendFilt program. And essentially what this program does, I guess you don't need to look at the code, but it takes in a string as an argument, and over the network will send out the proper commands to write new code into the packet filter's code memory. So that's what I have going on over here on these terminal windows. So let me just reset this one here. Okay, so the first thing I'm going to do is I'm going to send a filter that accepts every single packet. So I can do that by running my sendFilt program with an empty string as its argument. So here, the FPGA is going to output in a second a little bit of a debug message that says I wrote the value 0 to address 4, the value 60,000 in hex to address C, the value FFF to address 8, and the value 1 to address 4. Address 4 is the start and stop register for the packet filter, so writing 0 to it will stop the packet filter. Then by writing to the right addresses here, we can put in new, virus and threat protection, we can write new instructions into memory. This instruction just returns FFFF, which causes every packet to be accepted. And then we write 1 to address 4 to restart the packet filter. So now if we go and look at our ILA, we see that we have 3 blips here, and I'm going to zoom in on one. If I can get there. All right, so this first packet is sent over axis stream, and it's that dead beef, beef cafe, cafe dead, 0, 1, 2, 3, 4, 5, 6, 7, and so on. And then shortly after, we have this TCP packet that I mentioned that it's sending out. And then we have the same dead beef packet all over again. Okay, so let me zoom back out. Now I'm going to put the trigger back on here. I'm going to change the filter. So something that I can do is I can do a filter such as ether04 equals 0x dead beef. This is the Wireshark capture filter language. And what I just wrote here in between the quotes is it asks if the first 4 bytes are equal to dead beef. So I'm going to send out that filter, and you'll see here that my debug messages are going to come back up here in a second. And now if we go over to the ILA, now we notice that we're only getting that first and third packet. So if we zoom in, it's kind of hard to zoom in sometimes. Yeah, see, there's our dead beef cafe, cafe dead, ABC, etc. Okay. So we'll run the trigger again. One thing that we can also do is we can say, well, hold on, I only want proper TCP packets. Okay, no problem. The filter spec for a TCP packet is just TCP like that. And we'll see that it'll write the program here in a second. Give it a minute. Yeah, there it goes. This is a longer program because it has more things to check. And we go in here, and now we notice, oh look, we're only getting 1 packet now. And if we zoom in, we can see that it is this TCP packet that the fake data is sending out. And I'll put the trigger back on here. And the last thing I'm going to do is I'm going to send a filter that asks for UDP packets. And of course, there is no UDP packet being sent by the fake data. So if we go over to my ILA, we'll see that it's just waiting for trigger forever. It's never refilling. What you see here is what's left over on the last time it triggered, but it's no longer triggering. And of course, just for the hell of it, we can go back to accepting all packets. And now our trigger is going again. Yeah, you can see it going. Okay, that's it.